Hey everyone, so this video is all about the intermediate value theorem. So we kind of talked a little bit about this on Monday when I saw you guys in class, and we watched the video of the speedometer in my car, right? We talked about how even though you can't see the speed growing between 20 and 40, we know that at some point we were driving 34 miles an hour and 27 miles an hour and 58 miles an hour, all things like that, okay? So that is really the big idea behind the intermediate value theorem. So now we're actually just going to get into the wordiness of it, okay? Before we do that, I want to look at a specific example to kind of help make the words a little bit clearer. So the first thing I want to do is look at this function f of x equals x minus 2 squared plus 1. And hopefully you guys can look at that and you can see that that's a parabola that's just shifted to the right 2 and up 1. So we're going to draw a quick picture of what this would look like. All right, 1, 2, 3, 4. I'm going to go up to 5. So I'm just going to worry about the first quadrant because that's really what we're going to focus on right now. But if we plugged in 0, so 0 minus 2 is negative 2, negative 2 squared is 4, plus 1, there's that 5 that I wanted. If I plug in 1, 1 minus 2 is negative 1, negative 1 squared is just 1, plus 1 gives me 2, so we're at the point 1, 2. And if we plug in 2, 2 minus 2 is 0, squared is 0, plus 1, so we get 2, 1. And that should make sense as our vertex, actually, because we were shifted 2 to the right and up 1. And then we can just reflect our other points over. So the point 3, 1, and then the point 4, 5. And we have a nice parabola to look at. If Miss J could draw a parabola, that is. Okay, so by looking at that, we can tell right away that there's no problems with that, right? So let's look at the conditions for the intermediate value theorem. So f of x has to be continuous. Over the interval a to b. So we know that that parabola is continuous because it's a straight curve. There's no holes, there's no asymptotes, there's no jumps. We've talked a lot about continuous, and we know this is a polynomial, so it's clearly got to be continuous. So a and b, the interval a to b, is really just talking about these x values. A and b are the x values. Values, Miss J. So what I want to do is I want to look specifically at our parabola, and I want to look at the interval from 1 to 4. All right, so here's x equals 1, and here is x equals 4. So I'm really looking at this portion of my parabola. All right, those are my x values there. 1 would be my A, so A would be right here, and then 4, we're going to call that our B, so B would be right there. So if f of x is continuous over the interval a to b, so cool, it's continuous from a to b, so that's the first condition. The second condition is that m is some number between f of a and f of b. Well, we need to think a little bit about what that means. So f of a really just means f of 1. So that's this value here. That would be 2. Okay? F of, and I'm going to write that actually, sorry, f of a equals 2. F of b, that's 5. Which means we want an m value that's somewhere between 2 and 5. So I'm going to pretend, I'm going to pick my m value as 3. All right, so I'm going to go ahead and label it on my graph there. And even by just looking, if I take y equals 3 and I draw it across my parabola, I can actually see 2 places where it crosses the parabola. Okay. But what we're going to guarantee then, our conclusion, sorry, I just got a little bit ahead of myself. Our conclusion is we can guarantee there exists a number C between A and B such that f of C equals M. And that's actually what I was just getting at. Sorry, like I said, I got a little ahead of myself. Here's M, right? The value of 3 that we picked. That's between 2 and 5. So what the intermediate value theorem tells us then is that because it's continuous and 3 is between 2 and 5, we can guarantee that there is a value on the parabola where y equals 5, or y equals 3, excuse me, because that's the M value that we picked. Okay, this theorem, it's really important to note, so I'm going to just put a little star down here. All this does is it guarantees that it will exist. But it doesn't tell us where. Oops. It doesn't tell us where. So this is called an existence theorem because it tells us that it exists, but it just doesn't tell us where. It's kind of like the car, right? We knew that it had to hit every value between 20 and 60, but we don't know when it was hitting those different values, and we don't know what was going on in between. We just know that it hit them at some point. Okay, sorry, I screwed that up a little bit, but hopefully you guys were able to follow along with me enough. Let's look at some actual examples and see how this applies to a real example when it comes to either our test in class or even the AP exam in May. All right, so suppose this should say f of x is 25 minus x squared. Can you guarantee a value c where negative 2 is less than c is less than 8, such that f of c equals 0. So the first thing we want to think about is this is a parabola. So we know that this is going to be continuous. That's our first condition, and we have to make sure that it actually meets the conditions before we can even think about using the intermediate value theorem. So we know for sure that f of x is continuous. All right, then we also want to look at what interval we're talking about. So we're talking about negative 2 to 8. That is the interval that we care about. And so it's asking us, is there a value f of c that would equal 0? So we need to figure out, this is going to be our m value that we talked about up here. We want m to be between f of a and f of b. So what we're going to do is we're going to figure out what is f of a and f of b. Well, f of negative 2 and f of 8. Let's actually find those values. So negative 2, so we're going to get 25 minus negative 2 squared. So this becomes positive 4. 25 minus 4 is going to give us 21. And then for f of 8, we have 25 minus 8 squared. 8 squared is 64. So 25 minus 64 would give us negative 39. All right, so if we look at those two values, 21 and negative 39, this function is continuous. And 0 falls between these two values. So yes, we can guarantee that there's a value. I don't know what it is, and I don't really care at this point in time, but I do know that it actually exists. So the explanation for this is a little wordy, but it does need to all be included in your answer. So we're going to write this. We always have to start with our conditions. So since f of x is continuous, because that's our first condition, right? Look back up at the top. F of x is continuous on our interval. So since f of x is continuous and 0 is between f of 8 and f of 2, negative 2, sorry. So f of 8 is less than 0, which is less than f of negative 2. So our first condition was that it was continuous. And we know that 0 lies between our two endpoints. Then, by the intermediate value theorem, so IVT, there exists a value C such that, oops, sorry, no, not such that. Then by IVT, there exists a value C in the interval negative 2 to 8 such that f of c equals 0. So we started with our two conditions and then we were able to go to our conclusion. So there's a value c in this interval such that f of c equals 0. And that's because from 21 to negative 39, we had to have crossed the x-axis at some point. All right, let's look at the next one. So we're given the same function, which is kind of nice, because then we can just say right away that we know f of x is continuous. All right, but now we're looking at a little bit of a different interval. So we're looking from 2 to 5. And we want to know, is there a value such that f of c equals negative 3? So negative 3 is this m value that we're going to see if it falls between f of a and f of b. So again, here's our a and our b. So we're going to figure out what is f of 2 and what is f of 5. So f of 2 is going to be 25 minus 2 squared. So 25 minus 4, that's our 21 again. F of 5 is 25 minus 5 squared. Well, that's actually just 0. So when we look at this, we have to remember our first condition is that it's continuous, and our second condition is that m has to fall between these two values, these two y values. Well, from 21 to 0, I don't know what's going on, but I can't guarantee that negative 3 is in there. It could be, I guess, but without knowing more about it, we can't guarantee it. So this one actually does not get to use the intermediate value theorem. So since negative 3 is not between f of 2 and f of 5, IVT does not apply. Intermediate value theorem does not apply. So in other words, we cannot guarantee a value c in this interval from 2 to 5 such that f of c equals negative 3. All right, so really our question was, can you guarantee it? And really the answer is no, we can't, because intermediate value theorem doesn't apply. So without other stuff, we're not able to get there. All right, I know it's kind of wordy, these explanations, but they do need to look like this, especially once you get to the AP exam. All right, so we're going to practice with it a lot with writing. But let's look at also what some multiple choice AP questions are going to look like. All right, so consider the function f of x equals x cubed plus 1, so that's our function, on the closed interval 1 to 3. According to the intermediate value theorem, there exists some number c in the open interval 1 to 3 such that f of c equals, and we need to pick an answer. So we have to remember that the intermediate value theorem, the first condition is that the function is continuous. Well, x cubed plus 1 is a cubic function, it's a polynomial, so we do know that it's continuous. All right. Then the second condition is that whatever this value is, f of c equals whatever, so this value we're trying to find must be between f of a and f of b. So in this case, f of 1 and f of 3, because the interval that we're on is from 1 to 3. So we're just going to find those endpoint values. F of 1 is just 1 cubed plus 1, so 2. And f of 3 is 3 cubed plus 1, which is 28. So whatever this value is that we're going to choose, it must fall between these two values, 2 and 28. Well, 0 does not fall in there. 1 does not fall in there. 3.56, that does. And 1.79 does not. So our answer must be C. 3.56 falls between 2 and 28. So that must be a value according to the IVT. All right. This one, again, a multiple choice question similar to the AP exam. But now we're looking at a table. So we know that f of x is a continuous function because it tells us right there. If the intermediate value theorem can be applied to the interval -4 to 4, so that's the interval we're looking at, what is the minimum number of zeros for the function on the interval? So it's asking for the minimum number of zeros because we don't truly know what else is going on. We only know what we can see from this table. But we do know that a 0 is going to occur anytime the sign changes. So if the sign changes from positive to negative or from negative to positive, then we have a 0. So looking at our f of x values, -2 to 1, the only way to have a continuous function and go from -2 to 1, you have to pass 0 at least once. All right, and then same to go from 1 to -2. If I'm at a +1 and I want to get to -2 and it's continuous, then I have to have a 0 there. And then we're also actually given a 0 right here at 0. So the minimum number of zeros for this function would have to be 3. All right. We have one more question to do, and then you guys will get to some practice. I know this video is a little bit longer. I'm sorry about that. But this is a good question, so you'll like it. All right. Let f be a continuous function. So f is continuous, such that f of 2 equals 5, f of 5 equals 2. Let h of x equal f of x minus x. All right. And explain why there must be a value for r for 2 less than r less than 5, such that h of r equals 0. So this question does not explicitly say intermediate value theorem, but by reading it, we should be able to tell that that's what we need. All right, intermediate value theorem is always going to be a part of any question where you are asked to guarantee that a function takes on a particular value. So since we're asked to determine if there's this r inside of h of x, that h of r would equal 0, we're asking for a particular value. So we know that intermediate value theorem is going to be our friend here. All right, so When we look at h of x, the first thing we have to decide is it continuous? All right, h of x is just f of x minus x. Well, f of x, we were told that that's continuous. And then minus x, well, x is just a line, and that's continuous. So the difference of two continuous functions is continuous, which means h of x is continuous. So that's our first condition. All right, then we need to figure out the values of the endpoints. Well, the interval we're looking at right now is from 2 to 5. So we're going to figure out what is h of 2 and what is h of 5. H of 2 is f of 2 minus 2. So that would be 5 minus 2, which is 3. And then h of 5 is f of 5 minus 5, which would be 2 minus 5. So we get negative 3. And we're looking to see if h of r equals 0. Well, to go from 3 to negative 3, we had to have passed 0. So intermediate value theorem can be used here. So again, our explanation is a little wordy, but it has to all be there. So we're going to start with our conditions. So since h of x is a continuous function, so that's our first condition. H of x is a continuous function. And our second condition says that m has to be between f of a and f of b. So in this case, our m is 0. So 0 is between h of 5 and h of 2. That's our second condition. Then by IVT, intermediate value theorem, there exists a value r in the interval 2 to 5 such that h of r equals 0. So we start with our conditions and then we can go to our conclusion. And if you notice, we're rewording a lot of what's already here. So there must be a value r in the interval such that h of r equals 0. So we said by IVT there exists a value r in the interval such that h of r equals 0. All right. I know that was a really long video. I'm so sorry. Take a 5-minute break, go to the bathroom, do whatever you guys need to do. And then when you come back in 5 minutes, you're going to work on the practice in your packet. And the last 15 minutes of class, you guys are going to take a quick formative assessment for me so that I can see where we're at on Thursday. And then we will study Thursday in class, and your test will be on Friday. So work together, answer each other's questions, help each other out, check your answers on Google Classroom, and I'll see you guys on Thursday. All right, bye.